Okay, welcome to our deep dive. We've got some really interesting source material here, focusing pretty tightly on geometry, specifically circles.
That's right. It's all about the foundational definitions, the terms, the basic relationships that define what a circle actually is.
Yeah, and our mission today is to unpack all of that, to get beyond just the terms and really understand the core ideas the sources are laying out about circles, making it clear and hopefully pretty engaging.
Absolutely. Let's get into it.
So the sources kick off with the most basic thing. What is a circle, fundamentally?
Well, they really stress it's about position and distance. It's the path you trace, if you keep a point moving, always the exact same distance from one single fixed point.
Right, the fixed point is the center.
Yeah.
And that fixed distance, that's the radius. It's quite elegant, isn't it? How that simple rule creates this perfect shape.
It is. And the sources do note sometimes circle means the boundary, the path itself, but technically it can also mean the whole area inside.
Ah, okay. So the boundary specifically is the circumference.
Exactly. And once you have the radius, the diameter follows naturally. It's that line segment straight across the circle through the center, touching the circumference at both ends.
And the sources highlight that key relationship. Diameter is always just 2 times the radius. Dead simple, but yeah, totally fundamental.
Absolutely. And then things get interesting when you look at how other lines interact with that boundary, with the circumference.
Like a chord.
Precisely. A line segment that just joins any 2 points on the circumference doesn't have to go through the middle.
And the sources drop a neat fact there. The longest possible chord you can draw. It's always the diameter. Makes sense, as it's the only one guaranteed to pass right through the center.
Right. Now, if you have a line that doesn't just stop at the boundary but goes through the circle, hitting it at 2 points, that's a second in.
Okay, so it cuts through. But what about a line that just grazes it? Touches it at only one single point?
That one's called a tangent, and the sources point out something really crucial here.
Oh yeah, what's that?
At that specific point where the tangent touches the circle, the point of contact, the radius drawn out to that point is always perfectly perpendicular to the tangent line.
Always a 90-degree angle, right there on the edge.
Always. It shows this amazing precision baked into the circle's geometry. That's a really powerful relationship the sources identify.
Okay, so we've got the circle itself and lines interacting with its edge. What about dividing the circle up? The sources talk about arcs, right?
Yeah, an arc is really just any continuous piece of the circumference. You could say the whole circumference is the full arc, in a way.
And a semicircle, that's just half of it.
Exactly half. It's what you get when a diameter slices the circle neatly in 2 equal parts.
The sources also talk about minor and major arcs.
Right. It depends on whether they're smaller or bigger than a semicircle. If you draw 2 radii from the center, they'll naturally cut the circumference into 2 arcs. The smaller one is the minor arc.
And the bigger one's the major arc. Got it. And the angle between those 2 radii at the center is linked to the minor arc.
That angle is what we say the minor arc subtends at the center. It defines the arc's size, really.
Okay, moving from the edge inwards. What about a sector? Sounds like a slice of pie.
That's a pretty good analogy. It's the region bounded by 2 radii and the arc that they cut off between them.
So like arcs, you can have a minor sector and a major sector.
You got it. The minor sector goes with the minor arc, and the major sector goes with the major arc. It's the area enclosed.
Right. And then there's also a segment. How's that different?
A segment is bounded by a chord, and the arc it cuts off. So instead of 2 radii from the center, it's a straight line chord cutting off a piece.
Ah, okay. So every chord creates 2 segments.
Yep. There's the minor segment bounded by the chord and the minor arc. Crucially, the sources note this one doesn't contain the circle's center.
And the major segment must be the other piece bounded by the chord and the major arc. And that one does contain the center.
Exactly. It's all about whether the center falls inside that particular piece.
The sources also touch on location, like inside versus outside.
Yeah, the interior and exterior. Pretty straightforward. But they give a neat way to tell precisely where any point P is relative to a circle with center O and radius R.
How's that work?
It's just about comparing the distance from the center to the point OP with the radius R.
Okay, so if OP equals R,
The point P is right on the circumference.
and if OP is less than R,
It's inside, in the interior.
and greater than R means it's outside in the exterior. Simple distance check.
Exactly. Then they briefly mention groups of points or circles, like concyclic points.
Right, there's just 3 or more points that all happen to lie on the circumference of the very same circle.
And concentric circles.
Ah, those share the same center point, but they have different radii, like ripples spreading out. Looking back at this deep dive, it's amazing how that simple idea, a fixed point, a fixed distance, generates this whole complex, precise system.
It really does. We've gone from the absolute core definition to how lines interact, and then how those interactions carve up the circle itself into these distinct regions, like sectors and segments.
Yeah, it really highlights the rigor, doesn't it? Like diameter equals 2r, or that tangent being perpendicular to the radius. These aren't just descriptions, they're fundamental rules.
Absolutely. It's geometry built from the ground up on simple, clear principles.
So here's a final thought for you, the listener. We've seen how these basic definitions, stemming from just a point and a distance, don't merely describe the circle. They actually define how everything else lines, other points, areas interacts with it, creating all these parts.
It makes you wonder what other shapes, maybe even more complex ones, can be fully understood by breaking them down in a similar way. By looking at the fundamental relationships between their points, their lines, and maybe some defining measure like distance or angle.
Something to mull over as you look at the world around you.